Hello viewers, in today's class we are going to discuss one important definite integral in which greatest integer function is involved, right? So here we have to find the value of this integral from 0 to 1 and greatest integer x cube minus 1, right? So let us start. So here let us first call this integral as I, right? Now here once again we are going to take up the method of substitution. So let us take t is equal to x cube minus 1, right? So we are assuming t is equal to x cube minus 1. So this implies that x cube is equal to t plus 1 and x is equal to t plus 1 raised to 1 over 3, right? Okay, now let us differentiate both sides. So we have dt over dx is equal to 3x square, right? So the derivative of 1 is 0. Okay, so now we have dt over dx, and here we have x is equal to t plus 1 raised to 1 over 3. So we can write here t plus 1 raised to 2 over 3, right? So x square is equal to t plus 1 raised to 2 over 3. So therefore dx is now equal to dt over 3 times t plus 1 raised to 2 over 3. Okay, now see here we are changing the variable from x to t. So let us accordingly change the limits. So here we see that x varies from 0 to 1. So when x is equal to 0, then the value of t is 0 cube minus 1, that is minus 1, right? And when x is equal to 1, then t is equal to 1 cube minus 1, that is 0, right? So when x varies from 0 to 1, t varies from minus 1 to 0, right? Okay, so now this integral I can be rewritten as here we have minus 1 because x is 0, so t is equal to minus 1, so we have minus 1 to 0, right? And for x cube minus 1 we have t, so here we have greatest integer t, and for dx we can write dt over 3 times t plus 1 raised to 2 over 3, right? Okay, now here we have to make use of the definition of greatest integer function, and we see that t lies between minus 1 and 0, and when t lies between minus 1 and 0, then the value of greatest integer t is equal to minus 1, right? So here we can substitute for greatest integer t as minus 1. So now I becomes minus 1 to 0, and here we have minus 1 dt over 3 times t plus 1 raised to 2 over 3, right? Now this integral can be rewritten as I is equal to minus 1 over 3, and we have minus 1 to 0, and t plus 1 raised to minus 2 over 3 dt, right? So we take this term to the numerator, right? Now again here we can apply the method of substitution. So let us take y is equal to t plus 1, right? So therefore dy is equal to dt, and when t is equal to minus 1, y is equal to minus 1 plus 1, that is 0, and when t is equal to 0, then y is equal to 0 plus 1, that is 1, right? So we have changed the limits accordingly, right? So therefore this integral I becomes minus 1 over 3, and we have here we have 0 to 1, and for t plus 1 we have y raised to minus 2 over 3, and for dt we have dy, right? Now here we can apply the famous formula, that is x raised to n dx is equal to x raised to n plus 1 over n plus 1, where n is not equal to minus 1. So here the value of n is minus 2 over 3. So we have minus 1 over 3, and we have y raised to minus 2 over 3 plus 1 over minus 2 over 3 plus 1, and the limits of integration are from 0 to 1, right? So now here we have minus 1 over 3, and we have y raised to minus 2 plus 3, that is 1 over 3, and here we have 1 over 3, right? And now we can rewrite it as minus 1 over 3, and this will become 3 over 1, and here the limits are from 0 to 1, and we have y raised to 1 over 3, 0 to 1, right? So now this 3 and 3 get cancelled, and we have minus 1, and here we take y is equal to 1, so we have 1 raised to 3 minus when y is 0, so 0 raised to 1 by 3 is 0, so we have minus 1 times 1 minus 0, and this is minus 1, right? So viewers, the value of this integral is minus 1. So this is how we solve this problem.